Hello and welcome to my YouTube channel Statistics with R. In previous video, we saw how to detect outlier and leverage points. In this video, we are going to see how these points affects the summary output of a regression model. We are using the car library, which is companion to applied regression, and we are using the data which we have used in the previous video, where we were having the three variables: yield, our response variable, plant height, and the plant population as our independent variables. First, we will fit the model with all the observations in the model by including the outliers as well as the leverage points. So first we will fit our full model by first attaching the data set. Then we will try to fit the model by giving the name of the object as a model. lm function we will use to fit this linear model. Plant height, our first independent variable. Plant population, then we will mention the name of the data set as data. After running the model, first we will see that the outliers and the leverage points are belonging to which rows. For that, we will use the influence plot function, which is available within the car package, to see the rows which are the outliers and leverage points in our data set. As we have also already discussed this thing in the previous video, it means the 13th, 28th, 31st, and 34th row are the points which are affecting our regression model. So first we will remove these rows from the data, then we will create a new data set, and then we will try to fit the model with a new data set. First we will remove these points from the data set. So for that, we will first mention the name of the data where our data is, then we will put the long brackets, then you will use the minus sign, which stands for eliminating these rows from the data by using the concatenate function, because we have to remove the four rows: 13th row, 28th row, 31st row, and 34th row. Then we will put comma. That means we are basically removing these rows from the data, and we are keeping all the columns in our data set, and we will store this object into a new data set called new data. After saving this, eliminating the observations, now we know that we have stored the data into the new data file by eliminating all the observations which were the outliers or the leverage points. Now we will try to fit the reduced model. We will call it a reduced model. Reason being, we have removed the rows which were considered as outliers. Now we will mention the, or we will keep the name of the model as a new model. Then we will use lm function. We will keep our response variable as a yield. Then plant height and plant population as our independent variables. Here, we will mention the name of the data as a new data here, because in the new data, we have eliminated the observations which were considered as outliers. We will try to run the model. After running in the model, now we have fitted the two models. The first model we have fitted with all the observations. That means we have included those rows which were considered outliers. And then we have removed those rows from the data set by creating a new object called new data. Then we have fitted the reduced model by eliminating the observations from the data, and we have fitted a new model. Now we will check the summary of the both summary output of the mode models. First, we will check the summary output of the model, which is the full model where we have included those leverage points in our model. As you can see, the summary output of a regression model, the plant height is not statistically significant as depicted by the p-value is greater than 0.05. Only it is saying the plant population is having a statistical significant influence on the yield. As you can also see, the value of R square is very low, 0.21. But the overall significance of a regression coefficient, we can check it by the p-value, which says our regression results are statistically significant. So this is the summary output of the full model where we have included outliers. Now we will check the summary output of a model where we have eliminated the rows which were considered as outliers. So we will check the summary Now, this is the summary output of the new model where we have removed those outliers and leverage points. As you can see, the summary output, now the plant height is coming to be the statistical significant and plant population also, because in the full model where we have included those leverage points, that time the plant height was not statistically significant. Now it is showing the statistical significant influence on the yield along with the plant population. As well as you can see, the value of R square has significantly increased from 0.21 to 0.36. And the statistical significance as depicted, the p-value has also increased. So it is an indication that, so this is how there's leverage and leverage and outliers basically affect our regression model. And what is the alternative to the model if we were having outliers to the model? Because alternative is that whenever we have these leverage or these points which affect basically the regression model summary, as we have seen, the alternative is to use one of the important regression model which we call the robust regression models. Because when we fit the linear regression models, we are basically saying that these are the OLSS regression, because it's based on the OLS method of estimation for estimating the parameters. And this OLS estimators which we have fitted are basically very sensitive to the outliers and these leverage points. So when in our data point we are having these leverages, we should fit the robust regression. By robust means it is not sensitive to the outliers and these leverage points. And this robust regression, what it does basically, it changes the weight of the residuals. As in OLS regression, all the residuals are having the same weight, but in robust regression, the higher residual is having the low weight, and the lower residual is having the higher weight. So this is how these points are basically influencing our the summary output.